let's take a look at a couple examples of adding and subtracting scientific notation. Now, for this, we're going to take a little bit different approach than we did with multiplying and dividing. For this, we're going to follow a couple steps. We're going to change the scientific notation forms into standard form, add or subtract them, and then we're going to just change it back into scientific notation. In the next lesson, you'll learn how to use a calculator for scientific notation, which is another way and another tool that will help you solve problems like this. So the first one, we're adding those two scientific notations. So like I said, we're going to change them into standard form. So this first one, I'm going to take my exponent of 6. It's a positive number, which means it's representing a large number. So I'm going to move the decimal 6 spaces to the right. Fill it in with zeros. The next one, it's 10. So I'm going to make 10 spaces to the right. 2, 3, 4, 5, 8, 9, 10. And then fill in with zeros. And I'm going to line up my numbers and add them up. So I'm going to put the 8,064,640,000 under here. Okay. Now at this point I'm going to change it back into scientific notation. Now you want to be careful because if you just plug this addition into your calculator, it will not necessarily give you back a standard form number. And until we go over how to look at standard form scientific notation in your calculator, the best way to do this is just by hand. And it just takes a few seconds. Now we want to figure out how many spaces to move the decimal back between the 1 and the 3 to make it a factor of between 1 and 10. So I'm just going to start at the end because that's where my decimal is on a whole number. And my decimal is going to end up right here between 1 and 3. So 1.33484. Now it's a large, well, the factor has a lot of digits, but you want to include all of them except for the zeros. And we want to count how many spaces we move. So it looks like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So, oops. There we go. Times 10, and then my power is 10. So my final answer in scientific notation would be this number here. Okay, let's do the same thing with the next problem, except now we're subtracting. So 7.83 times 10 to the 8th. We're going to move that 8 to the right. 2, 3, 4, 5, 6, 7, 8. Put your zeros in here. Same thing for the second number. 7 spaces to the right because it's representing a large number since it's a positive exponent. But keep in mind if you have a negative exponent, you would be moving the other direction. 1, 2, 3, 4, 5, 6, 7. Fill the empty spaces with zeros. Now we're going to line up our numbers and subtract them. And I just don't have enough room to rewrite both numbers, but I probably would do that if I was doing this on my own, with my own space, just that I could see all of it and not have that extra number in there. Now we're going to need to borrow a little bit. Okay. So here's my number. And I need to change this into scientific notation, so I'm going to count how many spaces I need to move the decimal to get in between 7 and 7. So 1, 2, 3, 4, 5, 6, 7, 8. So my scientific notation number would be 7.7139 times 10 to the 8th power. And again, you can see I kept all the numbers that are non-zeros in my scientific notation answer. but also included my exponent and my power of 10 as well. So that just gave you a few examples on how to complete the problems with scientific notation when we're adding and subtracting. If you had a problem where you had mixed forms, like you had one scientific notation, one standard, you'd only have to change the scientific notation to standard, then follow your operation, and then again change it back to scientific notation.